Hello everyone. We have completed the finite automata without output section. So in finite automata without output, there are total three categories. First is deterministic finite automata, second one is non-deterministic finite automata, and the last one is epsilon non-deterministic finite automata. So you can refer in the previous videos for this finite automata without output section. Now in this video, we learn finite automata with output. It means these machines can take input as well and generate some output or generate some output on the particular machine. Okay, so if you given some input, let's say input string input alphabet A, then the particular output is also generated. So let's see the definition first. Finite automata with output is classified into two different machines. One is Mealy machine and the other is Mealy machine. Okay, Mealy machine and Mealy machine consist of total 7 tuples. The 7 tuples are Q, sigma, Q naught, delta. Here final state is not present. Here present is capital delta and lambda. Okay, so there are total 6 states, not 7 states. There are total 6 tuples present in the Mealy machine and as well as Mealy machine. So you already know the symbols. What are these symbols? Q is finite set of state, finite set of states. Okay, next one is sigma. Sigma is input alphabet. Then delta. Delta is transition function, and here in both Mealy and Mealy machine the transition function is same. The transition function is Q cross sigma tends to Q. Okay, so if you observe, this transition function is present in deterministic finite automata machine. Deterministic finite automata machine also have the same transition function, Q cross sigma tends to Q. So it implies that finite automata with output, Mealy machine and Mealy machine, both are deterministic in nature. Both are deterministic in nature. We cannot call it as a deterministic finite automata. We call it as a deterministic in nature. Next is Q naught. Small q naught is the initial state. Then capital delta, it is called as capital delta. Capital delta is output alphabet. Output alphabet. So in Mealy and Mealy machine, we have input alphabet as well and output alphabet as well. Now the last symbol, lambda. Lambda is in Mealy machine is Q tends to capital delta, but in Mealy machine lambda is Q cross sigma to capital delta. So these two machines are differ in their particular lambda, and lambda is called as output function. It is called as output function. So in DFA and DFA section, transition function is different, but in case of Mealy machine and Mealy machine, output function is different. Output function in Mealy machine is Q tends to capital delta, and in Mealy machine it is Q cross sigma tends to capital delta. So let's take an example. It will be more meaningful to understand the concept with the help of example. So you note it down the definition. After that I will take one example. So let's first consider Mealy machine. Let's say I have a transition diagram. So here output function is stated that every state is associated with some output alphabet. Every state is associated with some output alphabet. So we have denoted every state along with their particular outputs. So let's say output is Q0, 1, input state is Q0 and output is 1, and here Q1 and output is 0. Output is 0. On A it will remain as in the same state, and on B it will go to another state. Here on B it will remain in the same state, and on A it will go to the previous state. Okay. So first you need to identify what are the input alphabets and what are the output alphabets, because it is very important to understand the difference between input as well as output alphabet. So here input alphabet sigma is A, B, and what is the output alphabet? Output alphabet delta is 0 and 1. Okay. Now if I take any input string, let's say W is equal to AB, and if I trace the input string AB, then I will get output as, let's say, A and B. So Q0 is the initial state. Here Q0 is the initial state. So 1 is the initial state. So I started with initial state. Initial state will itself produce an output 1. So I will get output 1 in the starting phase also. And then after reading input alphabet A, I will remain in the same state. Remain in the same state means Q0, and Q0 will produce output 1. Now if I read input alphabet B, I will go to the state Q1 and produce output 0. So if you observe, our input string length is 2. AB is of length 2, but the output string produced, in the machine is of length 3. It means that in Mealy machine, if input string is of length, let's say n, then output string produced will be of length n plus 1. Remember that it is very important. If an input string is of length n, then the output string produced is n plus 1 in Mealy machine. Now let's take an example of Mealy machine also. Let's say I have a Mealy machine. Q0 and Q1 are the two states. On input A, it will produce output 1. On input A, it will produce output 1. So here the important thing is, if you present at let's say state Q and seeing some input alphabet, then the output capital delta is produced. So I am at state Q0, I see input alphabet A, then the output produced will be 1. Okay, so for input state, for some input alphabet, the output is associated. Okay, and for let's say B, it will produce an output 0. Similarly, on state Q1, if I see input B, the output produced will be 0. If I see input A, the output produced will be 1. Okay. Now for this machine, for this Mealy machine, if I have an input string, let's say AB, the same input string which I have taken in the Mealy machine also. If the input string is AB, what will be the output produced? So AB. So first of all, I will start with Q0 state. Q0 is the initial state. Q0 on A will produce output 1 and remain in the state Q0 itself. So it will remain in the state Q0 itself and produce output 1. Q0 on A will go to the same state Q0 and produce output 1. Now on Q0 on seeing small b will go to Q1 state and produce output 0. So here the output string obtained is 10 on seeing reading the input alphabet AB. So input alphabet string of length is 2 and the output string is also of length 2. So then this implies that in Mealy machine, if input string is of length, let's say n, then the output string will be of length n plus 1. Will be of length n. Okay, input string is of length n, then the output string produced will be of length n. Same it. But in case of Mealy machine, the output string produced will be of length n plus 1. Okay, so in the next video we will see various examples related to Mealy and Mealy machine.